Okay, so the first thing we're gonna do, when you add matrices, this is the easiest part. Add your x's, add your y's. Okay? Not really x's and y's, but you add your rows and columns. So if we look at A plus B, it's gonna be a 2 by 2, and you just add. -2 and 4 is 2. 1 and 3?
4, 9,
Yep, there you go. That's your answer. Easy. Okay, so now we're gonna go B minus A. So we're gonna have 2 by 2. B minus A. So we got 4 minus -2. 6. Let's go top right. So we got 3 minus 1.
2.
2. Bottom left, we have 6 minus 3. And bottom right, we got 1 minus 4. -3. Cool? Easy, okay? Now, I'm asking you to find B plus C. What is the dimensions of our matrix B?
2 by 3.
2 by 2. What's the dimensions of matrix C?
3 by 3.
3 by 3. Do they have the same dimensions? No, so this one's not possible. Easy. Okay? Now, what you could also do is multiply by a scalar, okay, which is just multiplying by a constant. Okay, they call it a scalar. We call it scalar multiplication. Essentially, all it is multiplying by a constant. Okay, so when it says 1/2 E, you're just going to take that matrix E and you're going to multiply by a half. So what happens to my matrix? Instead of -2, what is it? -1. 1.5, 3 over 2. Are you going down, Bryce?
Yeah.
Okay, and then a half. Okay, then we're going top right. We got what? -1/2.
0.
0, 1. There you go. Cool. All right, go ahead and do the next two. So first multiply by your scalar, then subtract. The next one multiply by your scalar and then add. You're done with both already, Courtney? And the third one? Quick. You quit. Already done with them? I'm gonna put you on the spot.
Well, from the spot. Oh, you have to do this one, Bob?
What was your sandwich?
Sorry.
Yeah.
Could use some mac and cheese.
I know you look very disappointed. All right, Isaac Newton.
Wait.
What? Give me the answer.
-10.
What?
What?
Hmm?
Just
Wait.
That's right. That's right.
-13.
Uh.
3. -10. 3, 1, 8, 7, 4. Is that wrong?
Should be -7.
Wait. Okay. And then 18, 16, 30, 34.
18, 16, 33, what?
Yeah, 4.
Is it 20?
Nine.
I got 9.
9.
5. Yeah.
5 and 4.
Yeah. Guess I can't add.
Last one!
Not possible.
Not possible.
Yeah.
Alright, so adding and subtracting, super easy. Okay, multiplication, not so much. Okay, so multiplication, you don't just multiply the two things together. Okay, that's not how it works. So with multiplication, okay, in order to multiply matrices, they have to have the same inside or the same middle dimensions. Okay, so that means if you have a 3 by 2 and a 2 by 2, can I add those together?
No.
No, but I can multiply them because your dimensions on the inside are the exact same. Okay? But I cannot multiply a 2 by 3 and a 2 by 2. Why is that?
So inside is different.
Because they're not the same. Yeah. Row by column. Always row by column. Yep.
Oh.
But, okay, if you multiply these two guys together, this 3 by 2 and this 2 by 2, okay, we can because they have the same middle pieces. Your resulting matrix is going to be the outside dimensions. So the inside tells you whether you can multiply them. The outside tells you what you're going to get. So what's the dimensions of my new matrix? 3 by 2.
Oh.
My matrix is going to be, inside tells you if you can actually multiply them. Okay? Now, the description is weird of how you do it, but you are going to take each element in a row, okay, times the corresponding element in a column, and then you are going to add those values together, and that's going to give you your new element, ij. Okay? So it sounds weird. We're gonna go through it and I'll show you what it looks like. Okay. So first one, if I'm gonna multiply A times B, let's first figure out can I? So this is a 2 by 2. This is a 2 by 2. Can I multiply them?
Yes.
Yes. What's my resulting matrix gonna be?
2 by 2.
A 2 by 2. So that's what I'm gonna do. I'm gonna draw out almost like if I have a 2 by 2. Okay. Then what I think about is this first spot here. This is row 1, column 1. Right? That's in row 1, that's column 1. Okay, to the right of that, that's row 1, column 2. Bottom left, row 2, column 1, and then row 2, column 2. Okay? That dictates what you're going to do. Okay? So that first piece, okay, that row 1, column 1, we're taking row 1, and I highlight a lot of things. Row 1, column 1. Okay? What you're going to do is you're going to multiply the first two values. So -2 and 4. Multiply those guys. What do you get? -8. And then you're going to multiply the 1 and the 6. And what do you get? 6. And you add those values together. That's the first spot. Okay? Then let's go to the right. So now we're doing row 1, column 2. So what am I multiplying? -6, and then 1 and 1, 1. Okay. Then let's pop down below. So now we're doing row 2, column 1. 12 plus
24.
plus 24, which is 36. Yep, we can simplify later. And then last one we're doing row 2, column 1. So that's 9 and 4. Then we simplify. -2, 36, -5,
and 11.
13. And that's your matrix. It's cool.
What even is it called?
We'll do matrices with solving systems equations. So instead of solving them with elimination substitution, you can use it with matrices.
What's that for?
I don't know if you're going to the store and you're buying 5 pairs of shoes and 4 shirts, and you only have, I don't know, $42. Didn't you have one on your last worksheet? You had the gallons problem, same thing.
I didn't do that.
Well, of course you didn't do it. It was right there.
Dang.
Alright, now, question number 2, they want you to know, do you think BA is equivalent to AB?
No.
No, figure it out. Go find it, BA. What's my resulting matrix gonna be? 2 by 2? Okay.
Yeah.
Maybe I'll get it.
Okay, so now you're doing BA. So if it helps, maybe rewrite those matrices next to each other so you see that B coming first. So there's B, and then A. So you're gonna, see how this first part is row 1, column 1? So you're gonna take row 1, column 1, multiply your corresponding pieces. So 4 and -2 is -8, and then 9.
How do you know what pieces correspond with each other?
Whatever comes first.
Okay. Okay.
Okay. So then we've got row 1, column 2. So 4 and 12. Row 2, column 1. -12 and 3. And then our last one is row 2, column 2. So 6 and 4. So 1, 16, -9, and 10. What are your dimensions of E, or of A?
2 by 2.
2 by 2. What are your dimensions of E?
2 by 3.
3 by 2, because remember we do row before column. Can I multiply those together?
No.
No, these do not match. Not possible.
Is this not, wait, is the row not horizontal?
There's 3 rows in E,
Oh.
right? 3 rows, 2 columns.
How do you know which way I'll multiply? I get the row 1,
No,
column
it's just
1.
like, it's just weird.
So like,
Looking at it, you're
row
looking
1,
at it and saying
column 1, so you do the
3 in the
corresponding,
column,
-8
but
and
there's
9,
2 columns and then,
How do you know which ones are corresponding?
whatever comes first.
yeah, that's 2 by 3.
So this comes first,
Oh, okay.
this comes first.
Rows
Yep.
and columns.
1,
Alright.
2, 3
Yeah, but I
rows.
have columns first.
Rows before columns. Alright, let's go with CD. CD, we're doing a 3 by 3 and a 3 by 3. So what's my resulting matrix gonna be? 3 by 3. So I'm gonna rewrite it just because so you can see it. We got 1, 0, 2, 4, 1, -1. Multiplying by D, which is 2, and you don't have to rewrite it, you have it at the top there. 5, -1, 3, 1, 1, -2. And we said we're supposed to get a 3 by 3. So row 1, column 1, row 1, column 2, row 1, column 3. And you don't have to write those out, I just think it's helpful to see what you're looking for. Row 2, column 1, row 2, column 2, row 2, column 3. Row 3, column 1, row 3, column 2, row 3, column 3. Yeah, and that's helpful too. So what Jack's doing is he's like covering up the opposite rows and columns that he's not using. So we find that helpful so you know exactly what you're multiplying. So I'll go through it. So row 1, column 1. So I have -4, 4 and 0, See that? And so here's my -4. Here's my 4, and there's my 0. And then I would simplify later. And then I'm gonna go to the right of that. Do that next part. So now, I've got row 1, column 2. So -10, -1, 9. And then I got row 1, column 3. So -2, 1, -6. And then keep it rocking. So then I get 2, 0, and 0. I get 5, 0, and 6. 1, 0, and -8, 4, and 2. 20, -1, and -3. And 4, 1, and 2. There's your awesome matrix. Blue pill or the red pill? Which one do you choose? You ever seen the Matrix? Pick a blue pill or a red pill?
This is so complicated.
Which one's the bad one? The red one?
No.
Red ones if you wanna.
The blue one was that.
Blue one's done?
There's no bad one, it's just a choice. It's like when you go back to normal life.
You wanna go back to your life? You wanna live in a pod?
What was the red the
That's a
pod?
good movie.
Huh?
Wasn't red the pod?
Was red the pod?
Was it?
Red, or pod was Matrix, right? Because when he's in the pod, he's in the Matrix.
What pod? The little neck thing?
No, the pod.
Cause it's not like real life.
Yeah, he's in like this, like
It's like a
liquid.
simulation.
He's like in this liquid and
Well,
like.
yeah, but it's like real though.
Oh, the red
It's
pill
like-
confused me.
But like the simulation is what they're living in. That's what they're trying to figure
Yeah,
out.
red
But
pill.
they like,
The red pill
when
But
confused me.
they're not
They're
body.
in,
Their
like-
bodies are not there.
It's like a hologram.
Well, yeah, but you die. If you die in there, then you die.
In your pod.
Yeah.
You die.
They're in pods.
like they're in this
Yeah.
like.
I thought every
They're
time
in
you
this
died,
like
they
gross mush like
Oh,
liquid.
yeah.
Remember in the trees, and he's like connected here, 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 here.
Cause they're like they're in this
Yeah, like
Well,
trees
no,
and
but
pods.
doesn't
It's
he
like
get
this
out of
big
it though?
Me?
Doesn't he get out of it and then he's in the matrix?
See like those things?
No.
He's out of the matrix once he's out of the pod.
Oh, really?
I don't
Yeah.
know. They need to. Maybe we should watch it.
I think he just always.
Yeah,
gets
it's
out.
dictated
No,
because
right
we should
now.
watch it right now. That's so
I
complicated.
bet he's always.
Yeah, we
in
can
the
do that
Matrix.
like right now.
It's like a
Movie week.
Yeah, it's like these weird.
nest.
It's like-
See, it's in a tree, right?
But it's
Yeah.
red. It's the red pill.
It's a red pill.
Didn't he find out like he created it or something?
Yeah.
He created the Matrix. Yeah. Right.
Yeah.
Yeah.
How
I
does he not know that?
I just seen the movie.
Like he's
Sorry.
The white
So
don't
point
remember.
of it is just-
All right, last one.
You should watch that.
That's what
Last
Interstellar
one. Last one.
says.
What's the dimensions of E?
3 by 2.
3 by 2. What's the dimensions of A?
2 by
2 by 2. Can I multiply them?
No.
Yes.
Yes.
Oh wait. Oops.
Your
No.
insides match.
That's not possible. I don't do it.
So the
We multiply.
So your resulting matrix is a 3 by 2. So I'm gonna write that out. So we're doing a 3 by 2. We got those spaces. So we got row 1, column 1. Row 1, column 2. Row 2, column 1. Row 2, column 2. Row 3, column 1.
Is a cat?
Row 3,
What?
column 2.
No, they just show.
Multiply it up. We got row 1. Column 1. What do you get in row 1, column 1? So just 1? Cool.
Yep.
Row 1, column 2. So what do you get?
-6.
I got -6. Because you get -4, or you get -2 and -4.
Column 3.
What about row 2, column 1?
-6.
-6.
And then next one,
Three.
three.
Row 3, column 1. Row 3, column 2. Beautiful. Is there anything about?
Oh, bar.
Are we doing it?
No, I have to work from on the quiz, so no. So on your homework, there are word problems on the back, just don't do them.
As for you, I'm gonna be poor.